the next session on fluid mechanics. In this session, we are going to discuss the Pascal's law. We will see the derivation for this law. First, we will see the statement of Pascal's law. It states that the pressure or intensity of pressure at a point in a static fluid is equal in all directions. This word static fluid is very important because if the fluid is not static, that means if it is not at rest, then this law itself is not applicable. It is applicable for a fluid which is stationary at rest. So we will see that the pressure intensity will be same in all directions. So suppose if in a static fluid this is a pressure point, it is saying at a point. So at this point the intensity of pressure, say along the x-axis, the pressure intensity is Px, along y direction say it is Py, along z direction say it is Pz. So this Px will be equal to Py will be equal to Pz. This is what is a statement of Pascal's law. Now we will start deriving it. So we will start with the wedge shaped element. This is a fluid element in a fluid mass. This is a triangular or a wedge shaped element as you can see. So this angle is theta. I will label it as A, B, C. This angle A, B, C. At this point B the angle is theta. So let's say that this side AB, I will call it as dy because it is along the y-axis. AC is along x-axis, so let me call this distance as dx. And this distance is along z-axis, let me call it as ds. That is this length. Also, we need to talk about the pressure which is acting along the x-axis. So let's say the pressure along x-axis or x direction is Px. The pressure along y-axis is Py, and along z-axis say it is Pz. So these are the three pressures that we are going to encounter. Now let's talk about the pressure force. So let Fx. So let Fx be the pressure force along x-axis. Now when I talk about force, that is this axis, so it will be on this face AB. This is Fx on face AB. Now when I write this in terms of pressure, this will be pressure on this AB. On AB, if you see, it is along x-axis, pressure is Px into, we need to talk about the area. We know force acts perpendicular on this area, that's how pressure is generated. So for area, this dy is one length and we need to consider the width of this wedge shaped element as unity. So this area now becomes dy into the width, the area inside. So it is dy into 1. Now let Fy be the pressure force along y-axis on face AC. That's here. This will become the pressure along this axis, that is Py into area will be dx into 1. And when I talk about Fz, this will be the pressure force along z axis on the face BC. This is very important, this force is Fz. So this will be nothing but Pz into the length is ds, and in the perpendicular direction this value is unity. So that's how we define the pressure forces and the pressure on this body. Now if you observe carefully, this force is at an angle. According to the laws of mechanics, we can resolve this force along two axes, that is along the x-axis and along the y-axis. So when I resolve this, this will become Fz into either cos or sine. Now, how do we decide that? If you see, this is an interior angle. You can see this is a formation of Z. So, if this is theta, this alternate angle will now be theta. If this is theta and this total is 90 degree, so this angle will now be 90 minus theta. So, if this is 90 minus theta, this angle will again be theta, because the total angle over here again has to be 90. So this side will now be theta. So this will become Fz cos theta, and this becomes Fz sin theta. So that's how you can resolve this. Now we are going to talk about the forces which are acting on this wedge shaped element. So there are two types of forces. The first one is this pressure force itself that we have just discussed. And the second one is the weight of this element. For this derivation, you need to consider the weight of the wedge-shaped element. So let's talk about the weight. When we talk about weight, W, we know this is equal to m into g. This is the basic formula for weight. We know density is mass upon volume. So can I say mass is equal to rho into V just by cross multiplying? So when I substitute here for mass as rho V into G, this also becomes a formula for weight. We are talking about the weight of the element ABC, which is important. That is a wedge-shaped element we have. Now, let's not talk about rho, let's not talk about G, because these two are constant terms. We will talk about the volume of ABC. When you talk about volume, you should first think about its unit. The unit of volume is meter cube. This can be divided into meter square into meter. Meter square into meter becomes meter cube. Meter square we know is the unit of area. We know meter is the unit of a dimension. We can call it as length, width, height, whatever required. So here, if you see, this can be rho g into volume becomes area into width. Width is at 1, or the unity value which I have taken perpendicular to the direction of this screen. So this becomes rho g into. When I talk about area of this, since it is perpendicular, can I say it is half base height? Base is dx, height is dy. So this becomes half dx into dy. And the width that is perpendicular inside is 1. So this becomes rho g dx dy by 2. Now we don't have to solve this at this point. It is just a term that we require later on. So as of now, I have just calculated the weight. Okay, once this is done, let's talk about the static equilibrium condition that we are going to use. We know that we can use D'Alembert's principle and say summation of force along x direction is 0. So when I say summation of force along x direction is 0, I can calculate the forces along this direction. Let me assume any force which goes towards the right is positive. Now you are already aware about the D'Alembert's principle. I'll just give you a small view of it. When I say summation of force along any direction, it is following Newton's second law of motion, which is mass into acceleration of the body along that direction. Mass of the body does not change, it remains constant. But here if you see, the fluid is in rest condition. So there is no acceleration, hence this value is 0. The same law applies for y direction. Now there is no moment to be considered. So we have only these two equations to be used. So I have used the first one. This is according to static equilibrium condition. The first one of it is summation of force along x direction is 0. Now let's see the forces along x axis. One is Fx, which is moving towards right. I have said any force which goes towards right is positive. So this will be Fx. The other force which goes towards the left, you can see here Fz cos theta. It is going towards left. So I'll say it is minus fz cos of theta is equal to 0. Let's substitute. We have written fx as px into dy into 1. So let's substitute px into dy into 1 minus fz in itself is pz into ds into 1. Pz into ds into 1 is equal to 0. Now this ds is something which we need to find out. 1 anyways will have no significance. It is just multiplied with a value and it's the same value itself. So let's talk about this ds. Now if you see the wedge shaped element, it is something like this. This is theta, this is dy, this is dx, and this is ds. Suppose if I have to substitute this value of ds, can I talk about, okay, there is a cos term which I forgot to write, please add that. So we have to basically talk about ds cos theta. Now suppose if I have to substitute ds, if I talk about cos of theta, we know mathematically it is adjacent upon hypotenuse, so it is dy upon ds. So can I talk about dy to be ds cos theta? That is what I can substitute here, and I get therefore px into dy minus pz into dy is equal to 0. Now if I resolve, this is px dy is equal to pz into dy. Now dy can be cancelled on both sides because it is not equal to 0. So therefore, can I say px is equal to pz from this resolution? And I can mark this as equation 1. This weight term you can mark as A because this is what I'm going to use now. Now let's use the second static equilibrium condition, that is Fy is equal to 0. Along the upward direction, I'll say the forces are positive. So if you look at the diagram, you will see here Fy goes in the upward direction and Fz sin theta goes in the downward direction. So I have therefore Fy minus Fz sin theta, and also there is a weight acting in the downward direction is equal to 0. So therefore we have found Fy as Py into dx into 1 minus Fz is Pz into ds into 1 minus, okay, there is a sign term here, minus the weight value is rho g dx dy by 2 is equal to 0. Now since we are considering this element to be very small, I will remove this factor of weight and I'll assume that this is negligible. So if weight is negligible, what remains is py into dx minus pz into ds sin theta is equal to 0. I have considered weight as negligible. Therefore, this term can be assumed to be approximately equal to 0. So once this is approximately equal to 0, I get only these two terms. Now I need to talk about ds sin theta. If you look at this triangle again and you talk about sin theta, it is opposite upon hypotenuse. So I will have sin of theta will be dx by ds. If I have to find the value of dx, it will be ds sin theta, which is what I want to substitute. So what remains is py into dx minus pz into dx is equal to 0. Let's resubstitute. Py into dx is equal to pz into dx. This will get cancelled since dx is not equal to 0. So what remains is py is equal to pz. Let me mark this as equation 2. So when you see equation 1 and 2, can I say from equation 1 and 2, I get Px is equal to Py is equal to Pz. You have Px is equal to Pz. You have Py is equal to Pz. If A is equal to C, if B is equal to C, can I say A is equal to B is equal to C? This is a law of mathematics. So that's how you will prove that the intensity of pressure at a particular point in a static fluid will be same in all directions, which is the statement of Pascal's law. The pressure needs to be proved equal in all the directions. So with this, I end the session. I hope you have understood the derivation of Pascal's law. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.